In previous mathematics courses, you have studied linear and quadratic graphs. In this section, you examine and compare linear, quadratic, cubic, and quartic functions. As you work through the problems in this section, you will need to remember the definitions of even and odd functions. Even functions are functions where f of negative x equals f of x. For example, if I substitute x equals 2 and x equals negative 2 into a function and get the same y value for both, and likewise for every other positive and negative x pair of inputs, the function is an even function. Odd functions are functions where f of negative x equals negative f of x. For example, if I substitute x equals 2 and get f of 2 equals n, and when I substitute in x equals negative 2, the output is the opposite of n, and likewise for every other positive or negative x pair of inputs, the function is an odd function. Knowing these definitions will help you know which functions to compare on problem number 7. When comparing the graphs, think about the key features of each graph, including domain, range, symmetry, intercepts, and etc. In the task you did today in class, Logs Go Viral, you learned that continuous growth and decay are modeled with a base E exponential function. As you considered situations that involve continuous growth and decay, you practiced solving exponential equations using logarithms. In this section of your assignment, you will continue this practice. Remember that the continuous growth formula is A equals P times E to the RT, where P is the initial amount, population or money, etc. R is the rate of growth, T is the amount of time, and A is the final amount at time t. The continuous decay formula is the same, except R is negative, so you have A equals P times E raised to the negative RT. For problems 8 through 12, you will consider a situation of bacteria growth. Based on the information provided, you will need to fill in a table, create a graph, and find the equation. It is important to note that the amount of bacteria doubles every 15 minutes. Note that the table, equation, and graph all have t in terms of hours. This means that the rate is not 2, as you might initially expect. You will need to find the rate of growth. This will be similar to what you did on number 10 from the task in class. Here's an example of finding the growth rate for a function. A biologist is observing the growth of a newly discovered virus. The initial population of the virus cells is 12. The population doubles after 6 hours. Assuming the virus has continuous growth, what is the rate of growth? We start with the basic formula for continuous growth, A equals P times E to the RT. We know the initial population is 12. We also know that after 6 hours, t equals 6, the population will be twice as large, so 24. We put these values into our formula, and then we can use a logarithm to find r. So 24 equals 12e to the 6 times r, or 24 over 12 equals e to the 6r. So 2 equals e to the 6r. Then, taking the log, the natural log of 2 equals the natural log of e to the 6r. So ln of 2 equals 6r, or r equals ln of 2 divided by 6, which is 0.1155. Previously, you have used the properties of logarithms to rewrite logarithms so you can evaluate them. For each problem in this section, you will be provided with 3 logarithms that have the same base as the one you are evaluating. Using properties of logarithms, you will need to rewrite the logarithm you are given so that you can evaluate it using the values of the other logarithms provided. Here are the properties of logarithms you can use. Log base b of x times y equals log base b of x plus log base b of y. Log base b of x divided by y equals log base b of x minus log base b of y. And log base b of x raised to the k equals k times log base b of x. As you are trying to rewrite the logarithm, you should consider breaking larger numbers down into their factors. You should also consider equivalent fractions, since this may help you find logarithms related to the logarithms provided. Here's an example. Use the properties of logarithms and the values below to find the value of the indicated logarithm. Do not use a calculator to evaluate the logarithm. We are given log of 12 equals 1.1, log of 6 equals 0.78, and log of 7 equals 0.85. To find log of 1/2, we could start by rewriting the logarithm using the log of a quotient property. However, then we would have to know the logarithm of 2. Instead, let's consider an equivalent fraction related to the logarithms given to us. We know that 1/2 equals 6 over 12. Therefore, we will rewrite our initial logarithm, log of 1/2, as log of 6 over 12. Now we can rewrite this logarithm using our log properties and then find the value of the log. So, log of 1/2 equals log of 6 over 12, which equals log of 6 minus log of 12, or 0.78 minus 1.1, which gives us negative 0.32.